Our second last transformation is C. So we've done A, we've done B, and we're on to C. Now notice where the C is. The C is in the bracket with the X, which means it's a transformation on X. How is it going to work? Well, everything with X is opposite to what it appears. So if the green graph is my base graph, y equals f of x, and the blue graph is y equals f at x plus 2, and the red graph is y equals f at x minus 2, what do you notice? Well, when it's an x plus 2, the graph is shifted left. And when it is a plus 2, or a minus 2, sorry, it is shifted right. Now I had a little hiccup there because technically when your equation is x minus c, this is a c value that's greater than 0. When it is y is equal to f at x plus c, it means that you had to have put in a negative c value to make it appear positive. So when c is less than 0, you go left, and when c is greater than 0, you go right, which makes sense, but it's not the way it looks. So I never, ever, ever write it like this. I always go like this. If what's in the bracket is a plus 2, it's going to go left, so is shifted left. And if what's in the bracket is like an x minus c, so an x minus 2 or an x minus 3, the graph is shifted right. Now this one I don't feel like I need to go to Desmos and show you, although I'm like fighting the urge now that I've said it. But let's go to this guy. So describe how the graph of the function can be obtained from one of the base graphs, then graph the function. So the first thing we're going to do is we're going to start with the graph of y equals the square root of x, which hopefully everybody's getting more and more comfortable with, using x values 0, 1, 4, 9 to get the y values 0, 1, 2, 3. So let's plot those. Oh, I didn't make my grid big enough. That's okay. All right, then what do they want me to do? Well, now we're going to do our transformation. So what's happening? Well, we all can see that this is a transformation on x, which means which values are going to stay the same? The y's. So we're going to keep the 0, the 1, the 2, and the 3. Now again, these are hard to explain with tables of values. Like I literally just look at that, I'm like, hey, go left 3. Cool, done, same shape. But this video is trying to explain why. So if our equation is the square root of x plus 5, we're thinking about what do we need to do to the x value to keep the y value the same. So thinking about in here, if I want to add 5, and I know that I want it to be the square root of 0, then I know this x value has to be negative 5. I had to decrease my x value by 5 so that when the equation adds 5, I get back to 0. So knowing that, let's just do that with the other x values. So we're going to subtract 5. So this is going to be negative 4, negative 1, and this is going to be a 4. What's going to happen is that because we've subtracted for x 5 from each of the x values, we're going to get the correct table of values. So if we just check this one, this is the square root of 4 plus 5, which is the square root of 9, which, yay, is 3. So this is just trying to prove to you that when the equation has an x plus 5, so this is considered in that bracket with x, that the graph is shifted left 5 by subtracting 5 from the x. And again, honestly, if you put shifted left 5, I'm going to take it. The textbook's just like, well, how would you shift left? Oh, you're subtracting 5 from all the x values. They're just very verbose at the beginning to try to get you used to these transformations. So if I plot these points, I've got a point at negative 5, 0, negative 4, 1, negative 1, 2, and 4, 3. And what I've done, oh, that's 2. 4, 3. What I've done is I've taken each of these points. I've gone 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, right? I've shifted them left. And then all of a sudden that 9, 3 point comes out. And that is my completed graph. So let's just practice words. right? So if we look at this one again, we're going to start with the y equals the absolute value of x graph. And then the second thing we're going to do is we're going to shift where? Left or right? We're going to shift right. It's opposite as appears. So this is going to shift right 3. One big hint I can give to you is that how my brain does it is it treats anything in the bracket like of x as something that's a 0 factor. And so I have to set it equal to 0 and solve, which is what helps me reverse all of the operations on x. For this one, what are we going to start with? Well, we're going to start with the absolute value of x. And then where's this one going? It's going to shift left 4. So if we're going to write an equation for a function that has a graph with the given characteristics, so the first one is y equals 1 over x, but shifted left. To shift left, we know that we are going to add 5. Now, to add 5 to the x, it's literally going to go in the denominator with x. This might be a good place for Desmos. So let's go to Desmos. I've already put in y equals 1 over x, and I just want to prove to you that if you want this graph to shift to the left, then if you put the plus 5 in the bracket b, meaning in the denominator with the x, that's what's going to shift it. Okay, so you just have to put it wherever the x is. Let's look at the next one. So for this one, we want to shift it right, which means we know it's going to be a minus 4. So into my equation, we're going to put x minus 4 all cubed. All right, moving on to points. So we're going to get to our place where we can transform a piecewise function. So if you have a point 2,8 on your graph of y equals f of x, and we want to graph the transformed graph g of x, where g of x is equal to f of x minus 4, what are we going to do? Well, this is going to make us add 4 to our x values. It's going to shift right. So if I add 4, I'm going to end up with a 0.68. Again, we're going to start with that 0.28. What's this going to do? Well, it's going to make me subtract 2, and it's going to shift left. I can't stop describing. I like describing. So we're going to minus 2 from our x value, and we'd have a 0.08. So if we go to this graph, right, we're going to pull off those key points. Some of these graphs are getting repetitive. I've got a point at negative 3, 0. I've got a point at negative 2, 2. I've got a point at 0, 0. I've got a point at 2, 2. And I've got a point at 3, 0. What I'm going to do is I'm going to add 3 to all of the x values, opposite of what it appears. And what's my new graph going to be? So this is going to be a 0.00. This is going to be a 0.12. This is going to be a 0.30. This is going to be a 0.52. And this is going to be a 0.60. Or you could literally take this point and go, hey, I'm going to move right 3. 1, 2, 3. There it is. Move it 3. 1, 2, 3. There it is. 1, 2, 3. 1, 2, 3. And lastly, 1, 2, 3. So if you don't want to write out all the points and it's an easy transformation, you don't have to. There's no marks for that. The marks on the test will come from me checking that each of these points is correctly transformed. All right. That's the end of the horizontal translation.